So in this lesson, we're now going to be focusing on some arcs and angle measures in our circles. So we're going to be seeing some chords, some secants, and some tangents in this lesson, and how we can use those to help us define either arc or angle measures. So let's get started with our first formula here. And this is when we have either intersecting chords, secants, or tangents. So you can see here we have our secant AC and our secant BD that are going through our circle, and they are crossing with each other. And because of that, we have angle 1 and angle 2 that we can use some formulas to find. So the big deal here, if you want to find this angle measure, you have to take the average of the sum of the arcs that are opposite that angle. So for instance, and I'll color code this for you, the arcs that are opposite angle 1 would be arc AD and arc BC. So we would add those two together and then divide it by 2 or multiply by half, it's the same thing. And if we were trying to find angle 2, so the arcs that are opposite that angle would be arc AB and arc CD. So we would have to add AB and CD together, divide it by 2, and we'll get the value for that angle. So let's go ahead and look at an example with this so you can see how this works. So our first example, we want to find the measure of arc QT. So we're trying to find this arc right here. Well, if we're trying to find that arc, we're also going to need the arc that's opposite it, so RS. And we're going to need the angle that's in line with those two, which would be this angle right here at RUS. However, we don't have enough information right now to be able to find that. We do have the arc of 95 there, but we need the angle or the other arc in order to be able to find information out. So if we're doing our angle equals one of our arcs plus the second arc divided by 2. Right now we just have one of our arcs. But if you look, I have this 79-degree angle on the other side of the angle we were looking for. And we know something about linear pairs like this. Remember, linear pair just means that they're right next to each other and on a straight line. So that means that since linear pairs are supplementary, we can do 180 minus that 79, and we'll find out the angle that we're looking at is 101. So then in my formula, I can go ahead and plug that 101 in. Then since I'm trying to find the measure of QT, I'm just going to say that that's X for right now, so I have something to plug into my formula. So I'm going to be going through and solving 101 equals 95 plus X divided by 2. So the first thing that I need to do is to get rid of that dividing by 2. That's preventing me from actually getting access to where X is. So I'm going to go ahead and multiply both sides by 2. So I get 202 equals 95 plus X. And one last thing, I'm going to go ahead and subtract both sides by that 95. So in the end, I'll get that my value for X, which is my arc QT, is going to be 107. Okay, so you need the angles or the arcs that are opposite the angle, and then find basically the average to use that formula. Let's look at another type of intersection. So here we have a tangent line and a secant line. So our tangent line is this one on the bottom, the secant line is the one kind of going through the left. And we can see that this is cutting our circle into two different sections, right? There's section 1 and section 2. So on the circle intersections like this, these are like our inscribed angles. So what we're going to do if we want to find angle 1 is we're going to do half of the arc that goes along with angle 1. And if we want to find angle 2, we're going to do half of the arc that goes along with angle 2. So once again, really just like our inscribed angles for that. So let's look at an example of this. So example number 2, we want to find the measure of angle DBC. So DBC would be this angle right here. Well, in order to be able to find that angle, I need the arc that goes along with it, right? Because our angle is 1/2 of our arc. But I have the arc that's on the other side of that angle. Well, we've been doing this for a while. We know that the whole circle is 360. So if we do 360 minus that 192, we'll find out that there's 168 left for the arc that we need. So then all we have to do is go ahead and take half of that 168. So our angle DBC is going to equal 84. So not too bad, especially after having practice with those inscribed angles before. Let's look at our next one. This one I think is actually one of my favorites. So we're looking at an exterior secant or tangent intersection. So you can kind of see a couple of different situations how these could be drawn. You could have the first one where we have secants going through our circle from one exterior point. Our second one where we have a tangent on one side and a secant on the other, both from that exterior point. And our third one where we have a tangent on both sides coming from that exterior point. So really our formulas are kind of the same, even though things can be drawn a little bit differently. So the big deal here is your angle is going to be equal to 1/2 times the difference of your big arc in your circle minus your little arc. So what I mean by that is the big arc is going to be the larger of the two that's in between those two lines. So CE would be the big arc. In the second one, BD would be the big arc. And in this third one, from BD to C would be our big arc. Okay, so our big arc is all of those that are in orange. We're going to subtract from that the little of the two arcs that are in between those two lines. So for the first one, BD is that little arc. In the second one, BC is the little arc. And in the third one, BC is the little arc. So I just always think of it as your angle is 1/2 of your big arc minus your little arc. That way you don't have to worry about the changes in the different formulas based on how it's drawn. So we're going to look at a couple of examples of this just to get some practice. This one can be a little bit trickier to see when you're starting out. So example number 3, we want to find the measure of angle KLM. So I can see my angles right down here. And if you notice, the secant lines are cutting into our circle here. So we have this big arc that's between those two, which is the 140. And we have the little arc between those two, which is the 66. And this one's probably a little bit easier to tell because you definitely have some measurements for those, and obviously 140 is definitely going to be larger than 66. So my angle is equal to 1/2 times the big arc, which is 140, minus my little arc, which is 66. And then from here, really, we're just simplifying that down to find our value. So 140 minus 66 is 74, and half of that will give me an angle measure for KLM of 37. So not necessarily a difficult formula to use, it's just training yourself to identify your big arc and your little arc correctly from the circle that you have. Let's look at another one here, and sometimes these ones are a little bit trickier to see. So example number 4, we want to find the measure of angle PQR. So PQR, that angle is right here. So when we have the tangent lines on either side, your big angle is going to be the section from P to S and back around to R. And we can see there the measure that's on it, which is 313. So it's a pretty large arc for our example here. Well, in order to use our formula, we need to have the little arc as well, which is going from P to R. Now, you might be thinking, well, how are we going to find that? They didn't give it to us. Well, remember that our circle is 360 all the way around. So if we do 360 minus the 313 from the big arc, then we're left with a measure of 47 for that little one. And now we have both of our arcs, so we know that our angle is 1/2 times the big arc, which is 313, minus the little arc, which is 47. So once again, we're going to go ahead and subtract those. So 313 minus 47 is 266, and half of that is going to give us a value of 133 for our angle PQR. Okay, now what if you were given the angle measure instead of having both of the arcs in your picture? Well, it's still going to be working out the same way. We're still using that same formula. So our angle is 1/2 our big arc minus our little arc. So looking at our picture, we definitely have the angle. So right there, it's 56. Then we do have the big arc that's in between those two lines, which is 160. But what we're missing is a measure for this little arc, which I'll just go ahead and say that it's X to make it easier to plug it in. Well, from here, we're now going to have to go through and solve an equation rather than just simplify what we have. So there are a couple different ways you can do this. You can either distribute your 1/2 to both of your terms, or maybe you just want to get rid of it to get started. So instead of having a 1/2, I can multiply both sides by 2. So 2 times 56 gives us 112, and that's going to be equal to our 160 minus X. So from here, I can go ahead and subtract the 160 from both sides. So I get a negative 48 equals a negative X, and last step, divide by that negative 1. So in the end, my measure of arc MK is going to be 48. Okay, so a bunch of different formulas to go through. Of course, you're going to get to practice those on your worksheet, and we're going to have another practice activity to help you to get even more practice with those another day.